Morning, everyone. Good morning, Samila. Good morning, everyone. So let's start the class, please. Good morning, Mila. So carbon compound major sections today we are going to study. Today will have a long class, so because syllabus we have to finish and we have to start our mock test also, revision also. So get ready for it. Okay. Now listen. So carbon compound, what all we have studied till now. We have already studied about compounds of carbon, organic content. Good morning, Chotam. Now look here. They are fundamental organic compounds. They are known as hydrocarbons. Also, we have studied. Next part, they study the study of carbon compounds such as hydrocarbon derivative is called as organic chemistry. This content already we have finished. Okay. Carbon structure we have known. Why carbon is unique we have studied. Understood? Tetravalency property of carbon we have studied. Allotropes of carbon we have studied. What and all are the allotropes of carbon? Come on, quickly say. The allotropes of carbon are diamond, graphite, and Buckminster fullerene. The compounds of carbon are the allotropes of carbon are diamond, graphite, and Buckminster fullerene. Diamond, graphite, and Buckminster fullerene. Okay. After that, we discussed about diamond. We know that diamond is a bad conductor of electricity. It is the hardest substance known ever. After that, it is non-conductor of electricity. After that, it is synthesized. Means we can make diamond. The most important thing is we can make diamond. Yes, diamond, graphite, and Buckminster fullerene. We can make diamond. That's one of the most important thing that we can make diamond, and that is by synthesis process by very high pressure and temperature. In a very high pressure and temperature, we can make diamond. This is exactly the most important part. Now, next is this is exactly the tetrahedral structure of diamond. If somebody will be asking you the diamond tetrahedral structure, this is exactly the tetrahedral structure of diamond. Tetrahedral structure of diamond. Okay. Now next is the diamond electrified. Each carbon atom is bonded to three other carbon atoms in the same plane. So that's why it is considered as tetrahedral, or it is considered as tetrahedral. Understood? One will be connected to how many? 3, 4. Understood? So 4. Tetrahedral means it will be connected to 4. Why are the students absent? Some of the bond is double bond and thus valency of carbon is satisfied. One of the bonds is a double bond. Rest of the is exactly which check here. So graphite, we are going to talk about graphite. That was about diamond. Okay, tetravalency was for diamond. Now we are talking about graphite. So graphite is having hexagonal structure if you see, and none of the bond is exactly what you see. One of the bond is double bond it is having. Okay. So the double bond form is exactly making it very suitable. One of the bond is double bond, and thus the valency of carbon is satisfied in graphite. Graphite structure is formed by hexagonal array. If you can see, this is exactly what beta hexagonal. Jotam very nicely revised this one. Next is graphite structure is formed by hexagonal array. Graphite is smooth and slippery. Come on, Shamila, can you inform in the group that class started? It's very irritating. Good morning, Ashweta. It's very irritating when class is started. I already started at 6:15. What is this? Now it is good conductor of electricity. Why graphite is considered as competent? Why graphite is considered as good conductor of electricity? Graphite is considered as good conductor of electricity because of free ions, free electrons or free ions. Graphite is considered as good conductor of electricity. Understood? So if somebody will be asking you why graphite is good conductor of electricity, then what answer you are going to say? Graphite is good conductor of electricity because of presence of free ions. Because of presence of free ions, they are good conductor of electricity. Understood? So now we have already studied. Now Buckminster Fuller. So it is allotropic form of carbon. It is what we do? Allotropic form of carbon. How many carbons are present in Buckminster Fuller? There are total 60 carbons. That's why it is also called as C60. What it is called as C60. Why beta? Because how many carbons are present here? 60 carbons. How many carbons are present here? 60 carbons. Since 60 carbons are present there, so only it is called as C60. What it is called as C60. Now next part we are going to do. So C60 carbon atoms in a molecule of Buckminster Fuller. So formula is what? C60. Now we are going to, yeah, very good. It is the biggest form of carbon. Now another important thing is, this is exactly named after whom? This is named after American architect Buckminster because he has made this design. Okay, so what is the name of it? Buckminster Fuller. So what is the name of this allotrope? Buckminster Fuller. Understood. Now it is made with, can you see the pentagon? This is pentagon. Pentagon is 1, 2, 3, 4, 5. How many carbon are linked? 5. But here it is hexagon. 1, 2, 3, 4, 5, 6. Understood? So pentagon and hexagonal structures are there. So note down all these things. Pentagonal and hexagonal structures are there. Pentagonal and hexagonal structures are present 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 there. That's what it is exactly, very, very unique. So now please pay attention. So how many? 6 pairs. So write down for this. Beta hexagon. How many hexagon is present in C60 carbon? Note down. Note down one statement, everyone. It is also called as buckyball. It is also called as buckyball. Good morning, Tarun. Very late joined. It is also called as what, beta? Buckyball. What is the name? Buckyball. Bucky. Bucky. Ball. Ball. What it is called as? Buckyball. Buckyball. It is called as what, beta? Buckyball. Got it? What is the name given to it? Buckyball. Next, it will contain, it is having 26 membered rings. It is having how many 6-membered rings? 20. It is having 26 membered rings. It is having 26 membered rings. 26 membered means 20 hexagonal rings. How many hexagonal rings? 20 hexagonal rings. Understood? Like this hexagonal rings, it is having how many? 20. Can you see? 1, 2, 3, 4, 5, 6. So this ring, how many is present inside? 20. 20 hexagonal rings. Good morning. 20 hexagonal rings. After that, right? 12 pentagonal rings. 12 pentagonal rings. 12 pentagonal rings. 20 hexagonal rings. and 12 pentagonal rings. Morning. So 12 pentagonal rings, 20 hexagonal rings, and 12 pentagonal rings. 12 pentagonal rings and 20 hexagonal rings. Okay. Now already we know this, already we have done. Yes, 20 hexagonal and 12 pentagonal rings. You remember 12. Jotam, everybody, I hope you people are writing this. Once you have any doubt, you can ask me. T. So now look at, so catenation. So if somebody will be asking you about catenation, so you can say that carbon is having a unique feature. What is the unique feature of carbon? Self-linking property of carbon atoms are considered as catenation. Self-linking property of carbon atoms are considered as catenation. Understood? So catenation is self-linking property of carbon atoms. So now, next, straight, branched and closed rings. Carbons are exactly making with which type structures? Straight, branched or closed rings. Straight, branched or closed rings. Understood? So this is straight chain of carbon, this is branched chain of carbon, and this is closed rings of carbon. Understood? So three different forms of carbon will be there: straight, branched and closed. Straight, branched and closed. Note down this one: straight, branched and closed. Straight, branched and closed. Straight, branched and closed. Straight rings, branched rings and closed rings. So three different forms are there for carbon. Understood? Can you see for branch it's a closed figure. Understood? Sorry. For ring it is a closed figure. For branch there is a connectivity. So that's why it is called as branch chain. This is called as branch chain, and the straight one will go like this. So there are three different forms of carbon ring. Okay, linear, branched, and polygon. You can see like that also. Linear, branched, and polygon. That's true only. Linear, branched, and polygon. Linear, branched, and polygon. Absolute. So now we will go for the next one, please. Linear, branched, and polygon. Then beta, you might have seen here one thing. Yes, you might have seen here one thing. Carbon is connected with 1, 2, 3, 4. Maximum how many bonds will be needed is 4. Carbon maximum how many bonds will be needed is, check here, 1, 2, 3, 4. 4 are there. Carbon how many bonds are needed here is 4. Done. Now we'll go for the next one. Good morning, Kritika. Very late. Kavya, Kritika, Sharmila, Sophia, Anu, Mahalakshmi, Jasmita. Seriously, it's all the students now that Anupuram branch students now, they're seriously making me very angry now. Morning time, you must be present in classes. Now look here. We have only 1 month this month. Next month we are having mock test. From next month's test will start. 80% of the syllabus over. After that only test series we are going to keep. Okay. Otherwise we cannot be able to judge you how you are going to prepare. Get ready for it. Every day there will be revision. Understood? Because before syllabus revision, two chapters, one chapter I will hang, and most important thing is कि first we will start revising the content. Massive things like electricity. Once electricity chapter is over, in physics means everything will start revising. Got it? Carbonates compound is one massive chapter left. Understood? After that, in biology, which chapter left is heredity. Got it? Our environment in one day match. We will play that. That's not a big thing. 3 1 day 3 hours I will be sitting with all of you. I will be taking online class and we'll finish that our environment. That's not a big deal. This week itself I'm going to do. Okay. So this is our environment is not a big chapter. Carbon compound is a huge part. We need to study it very thoroughly. Second is electricity chapter, magnetism chapter, these two chapters. So science will be going parallelly. Plus, what we are going to do is maths. We will take secondly because today and tomorrow, huh? Circles now we are going to start circles because once height and distance is over, means circle chapter is going to be started. Circle chapter started means after that circle, related to circle and application. So 90% of syllabus, 95% of syllabus over. Got it? Which chapter will be left? That's it. Over. Correct one. So here area related to circle, circle and no application. No, that chapter. What you call surface area and volume. Three chapters are massive chapters are left. But here the most important thing is you people writing exams, you people writing tests. That's most important. Understood, Peter? You need to write the test very, very conformly. We will be having total revision, pattern of writing answers to everything. Okay. Now, Peter, look here. So tetravalency already we know. Tetravalency is what? Tetravalency means what? Carbon has a valency of 4 and it will have the capacity to combine with 4 more carbon atoms. Understood? That feature is called as tetravalency. What it is called as? Tetravalency. What it is called as? Tetravalency. So tetravalency is a unique feature of carbon which helps the carbon to combine with other atoms. I hope you might have understood this one. So now we will be going with Kartika. Good morning. Come on. So this is exactly about saturated hydrocarbon and unsaturated hydrocarbon. Before saturated hydrocarbon and unsaturated hydrocarbon, I need to discuss about isomers. Just give a heading. Just give a heading isomers. Everyone, get ready. I'm going to write down about isomers. What is the meaning of isomers and isomerism? Okay. Isomers and isomerism. Everybody, please take out your note. If it is not there, I'm giving you time. Take out your note. Start writing about it. At the time when I will be conducting test, I will not be asking you are knowing or not knowing. I'll directly backfire you. Ready? Give a heading isomerism. What is the meaning of isomerism? Right? The property in which the property in which the property in which, note down, two or more compounds two or more compounds the property in which two or more compounds have the same molecular formula but have different properties. have different properties is called isomerism. Is called isomerism. Please kindly note down, everyone, what is the meaning of isomerism. The property in which two or more compounds, the property in which two or more compounds have the same molecular formula but have different properties is called isomerism. But have different properties is called isomerism. So they are exactly, after that put full stop and write the compound showing this property. Write down the compound showing this property is called isomers. The compound showing this property is called isomers. This property is called isomers. The compound showing this property is called as what? Isomers. Very good. And they have different formula, and the compound showing this property is called as isomers. So beta, chemical molecular formula same, but structural formula different. The structures are different. Understood? The pattern with which we are making the carbon bonds are different. How it is going to be? Let's check this one out. So isomers exactly starts from where? First you see, you write for butane. From where? Butane. Note down, isomers will be starting from where? Butane. Butane. It will start generally from butane. See, methane, ethane, propane. Methane structure is this one. Don't draw with ethane. I am explaining this one. If you want, you can draw ethane, propane, they don't have isomers. No isomers. No isomers. No isomers. No isomers. Okay. So we are starting from butane. Four carbon atoms. Okay. Methane, ethane, propane, butane, pentane, hexane, heptane, hectane. Understood? Nonane, procane, unidecane, dodecane, tridecane, like that it is there. So, but first beta, methane do not have any isomers. Ethane do not have any isomers. Propane do not have. Okay. So, three different parts we have checked. Ring is not a part of it. Okay, ring we will discuss afterwards. Right now, only the second section I am doing. So please note down here, methane, ethane, propane, no isomers. Now we are going to proceed forward about butane. So butane isomers we will see. This is butane. Now, how many isomers of butane will be there? Come on, check this one out. So when we will start, Isomers of butane, you check this one, carbon, 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 one carbon chain will come. Jotam, are you there in the group? So this is exactly how many isomers. So you need to understand that when directly, good morning Satya, when directly like this chain is there, then it is called as normal butane. N-butane. N-butane means normal butane, or it is called as normal butane. Note down, I am giving you time. Isomerism and everything, I will teach very uniformly because in 11th and 12th and higher classes it will be much used. So you need to be very, very careful. Take your time and read. Draw it. This is called as normal butane. Or it is called as beta normal butane. Note down. Or it is called as normal butane. And the next part, two structures are there for it. How many structures are there for it? Sophia, good morning. Nice. So this is called as isobutane. When its branch will be there, it is called as isobutane. Isobutane. Note down normal butane and isobutane. So butane two structures are there, normal butane and isobutane. Two structures, what are they? Here, what are the two? Normal butane and isobutane. How we are writing it? N-butane and isobutane. Understood? Isobutane and normal. Iso means what? Beta? How many chain? One. One branch will be there. One branch means iso. One branch means iso. Two branch means neo. Two branch means neo. But for butane, how many isomers are there? Two isomers. Correct? Butane is having how many isomers? So you need to understand, they are telling that this, if including the main structure, see please pay attention, including the main structure we are writing, then 2 is there. Otherwise, only one isomer will be written. Understood? Because this is the main structure. This is the main structure and this is the, what you call, changed structure. Understood? So butane structure, if we will change, it will become like this. Correct? So because carbon atom, now you see, their formula remains the same. Is the formula same? Count the beta. 1, 2, 3, 4. Carbon how many is there? 4. Hydrogen count the 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So C4H10. Here also count the 1, 2, 3 and 4. Though chain is there, but again its formula is C4H10. That means the main structural formula remains the same. The structural formula is same, but the structure is different. Structural formula is same. What is the structural formula? C4H10. Yes, C4H10. Absolutely correct, Gopika. So C4H10. Gopika, today you punch your sister Kavya. C4H10. Got it? Because here the formula is, good morning Karnataka. So here C4H10 is there. C4H10. Understood or not? So how many are there, beta? C4H10 means what? You need to understand this one now. That structure remains the same. This was about butane. Now what we are going to talk about pentane. Understood? For pentane, how many are there? So different properties we are going to check. For pentane, how many structures are possible? Now for pentane, we are going to see. It will be C5H12. Saponification, beta. Saponification is different. In carbonate compound, we are going to study saponification also. Soap formation. Now look at it. This is exactly carbon 1, 2, 3, 4, 1, 2, 3, 4, 5. Okay. And now this is exactly 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So this is exactly straight chain. So here since straight chain is there, what we are going to say? Normal painting. Normal painting. Now we are going to make structures. So bond making means how many is possible? One, two, three, four. One we can draw like this carbon. This is called as isopainting. Understood, beta? So this is called as what? ISO painting. One branch is there. But you will be asking one question that can we shift the branch? Because branch shifting is possible now. So we can shift this branch here also. But when we will shift the branch from here to here, there will be no massive change. The name remains the same. That time, the parent chain will indicate the priority spice. The parent chain will be indicating from this direction or this direction. So location remains the same. Just understand this one. 1, 2, 3, 4. If I will put carbon here, then we need to start the naming from here. Got it? But if we will shift the carbon this direction, look here, then we will have to count from here. That means both things are same. Both things are same. That's the most important thing. Absolutely correct, madam. So both things are same. Everyone please pay attention here. So when you will be starting here, 1, 2, 3, 4. So first branch when I am putting, did you check here? The moment first branch I am putting, I am exactly putting here carbon here. Correct? No? So the moment I put carbon here, it got first priority and numbering I started from here. Understood? So how many are there? 1, 2, 3, 4. But in which location carbon is added? Second location. The moment I shifted this carbon chain, this carbon substituent, so this the moment it came here, the numbering started from here. So here in which location it is coming carbon? Second. So that means either you put here or you put here. That means things are same only. So that means how many single branches possible? Only one. How many single branches possible? Carbon because of its structure. Hi beta. Hi Sakshi. Carbon is because in quick I'm saying because of its self-linking property and it is exactly making polymer long chain carbon atoms are there. Because of that, everywhere carbon is present. Though it's present in Earth in very less amount, but its uniqueness is it is exactly present in most of the polymeric contents. Okay. Second thing is its tetravalency. Now we are going to talk about the next part. So next section, when we are doing it, we are exactly going to get the second chain beta. So one carbon total how many there? Five are there now. So can we do like this? One, two, three, four, five, six is coming. Correct now? So we can't do like this. So one we have to reduce. So how many double is exactly possible? CH3, H3, H3, H3. Done now? 1, 3, 6, 9, 12. Got it? So what is the name here? This is called as neopainting. We should not put dash and let it dash. Note down. It is called as what better? Neo-painting. Yes, absolutely correct, Sakshi. This is called as neo-painting. Note down, everyone. So this is called as normal painting, iso painting, and neo painting. How many isomers possible? Three major isomers possible. Normal, iso, neo. Normal, iso, neo. So three are there. Normal, iso, neo. I hope you might have understood this one. Normal, iso, and neo. Got it? So how many pentanes? How many isomers are there for pentane? Three. For butane, two. So like this, the maximum they will be asking. See, we talked about butane, pentane. For hexane, maximum they will ask. More than that, they will not. Neopentane means with a two branches coming. This is exactly one branch and another branch. Here, a single carbon is added with two other carbons. See here, this is parent chain. One you have to take as parent chain. So this is the one chain you have to take it as parent. With parent, how many are there? Substituents are there. So here two substituents are present. So one and two. In the previous one, two, three, four. This is the parent chain. In this parent chain, only one is there. So it is called as what beta iso. When two will be there, it is called as neo. Single, normal. Without anything is normal. Single is iso. Double is single is double is single is iso. Double is neo. Neo. Understood? Now we are going to go. So we have studied one very important part here. Got it? Now can we talk about how many IUPAC name when we will be talking about? So here you have to write 2 2 2. Here it will become 2 2 beta. See, this is first carbon, this is second. It will become 2 2 dimethyl propane. 2 2 dimethyl propane. I'm going to teach nomenclature beta. I'm going to teach nomenclature. In nomenclature, I'll tell you how to write names. Naming, name, how to write name, that I'm going to start. Okay, nomenclature part. So this is exactly what beta? 2,2-dimethyl propane. It is called as 2,2-dimethyl propane. 2,2-dimethyl propane. I hope you might have got that sheet. Now we will be talking about one isomer of hexane we will do. Come on, check this one out. Hexane we will do it. Are we ready for hexane? For hexane, what is the structure? C6H14. Okay, C6H14. When C6H14, nomenclature means beta, naming. Nomenclature means namkaran. In Hindi, we are calling it namkaran. Means what beta? Naming. Naming. Like everything will have a specific feature. Na? According to that, we give name. That is considered as nomenclature. Okay. So I am going to teach that. Don't worry. Now look at first hexane. What is the structure beta? Branch 1, 2, 3, 4. 1, 2, 3, 4, 5, 6. So here we can write directly because it is taking too much time for making bonds. CH3, CH2, 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 1, 2, 3, 4, 5, CH3, 6. This is called as what? This is first isomer. It is called as normal hexane. It is called as what beta? Normal hexane. Now second one beta. When 1, 2, 3, 4, 5, 6. So any one we will take as branch. H3, H2. We are taking branch means here one H will be there and this part will become CH3. One, see only one branch I am drawing. 1, 2, 3, 4, 5, 6. This is called as isohexane or another name what we are going to call. From here we will start naming 1, 2, 3, 4, 5. So 2-methyl pentane. Now this we can shift here also. Name will start from here. Same thing, isohexane. But beta, if I am starting from here, numbering I can start from here, correct? But the moment I will start from here, numbering will start from here. Got it? So what work we are going to do here is, we will make center one location is there. See, one location is possible, one location center possible. Because if we are placing here, what will all are the consequences? If we will place 1, 2, 3, 4, 5. Okay, if we will place here, same thing, numbering we will start from here. The moment we will place here, numbering will start from here. So this location is fixed. But we can do one thing now. One more structure is possible. Then we can place in the center part. Then we can place where? Center. So now we are going to place one more in center. So C, 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 C. This time it is coming in center. CH3, CH2, H, CH2, CH3. Then naming will become different. It will become isohexane only. Isohexane only. But name will become changed. What it is? 3 methyl. 1, 2, 3. What is the location now? 3. So write 3 methyl pentane. Note down. This is second number structure. This is third number structure. I hope Sakshi you might have understood. Everybody might have understood. That is second and third. Come on, note down, please. CH3. Okay. So three structures possible. We will talk about the fourth structure. Fourth structure, how it will be done? 1, 2, 3, 4, and like this we can do. Same location we can do. So what it will become? 1, 2, 3, 4. So that means what? It is H3, CH3, CH3. This part will become what it is? CH2 and CH3. Understood? But what is the name we are going to give this one? 2, 2, 2, 2. Dimethyl, methane, ethane, propane, butane. This time it will become butane. Understood? Because this becomes the main carbon chain. In main carbon chain, how many carbon is there? Count there. 1, 2, 3, 4. 4 means butane. 4 means what beta? Butane. 4 means called as butane. So this is either one structure possible, or we can do like this. 1, 2, 3, 4. We can place one carbon here and another carbon here. Up and down means does not matter. But one carbon, one carbon. Here, same itself, same parent chain, two carbons are there. But here in double differentiation is there, double dissection is there. So what we write? 2, 3 dimethyl butane. It is called as what beta? 2, 3 dimethyl butane. So where this is 3, 4, 5. That is final. That is final. Now more than this we can't write. Hydrogen, hydrogen, and this is CH. Note down the structure. Take your time. Note down the structure. 1, 2, 3 number I have written. I hope you understood what is the meaning of isomers very nicely. For beta hexane, how many isomers are there? Total count of 1, 2, 3, 4, 5. Branched we are not taking. Okay, sorry. Rings we are not taking. So 5 is there for hexane. More than this we can't draw because things remains the same only. Got it? 5. Absolutely correct. Online children, absolutely correct. 5 is there. Super. These many children are there. You can't put like button. Switch on like button here. Because we're not liking the class. 5 are there. Very good. Liking means I'm also feeling like okay, people are understanding. So now please understand this one. So this is exactly coming. How many isomers are there with the total? 6 isomers or five? 5 isomers. Understood. So this is exactly beta the story of isomer. Thank you so much. This is the story of isomer. After the story of isomer, we will be going towards the next section beta. So we will be talking about isomer. Understood? The formula remains the same, but structure is changing. That is considered as isomer. Now, beta, in hydrocarbon, I'm making a flow chart. Please draw this flow chart in your note. Got it? Draw the flow chart, beta. So, hydrocarbon, entire hydrocarbon, carbon will be divided into two sections. Okay. So now that is called as acyclic or open chain compounds. One is acyclic. Acyclic or open chain compounds. This is one. Second is cyclic or closed. Cyclic or closed or ring compound. 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 Cyclic or closed or ring compounds. Understood? A cyclic or closed or ring compounds. These are the things. Understood? Cyclic or closed or ring compounds. Got it? So now next one we are going to do here. Please check this one out. Now cyclic, acyclic will be of two types. Got it? Acyclic will be divided into two types. First is saturated and second one is unsaturated. Saturated and unsaturated. Saturated part is called as alkane. Single bond it is called. Alkane single bond forming. Formula, general formula. Cn H2n plus 2. General formula is Cn H2n plus 2. Cn H2n plus 2. Alkane name is there. Cn H2n plus 2. Note down alkane. Ansh. Yes, Ansh. So alkane. So beta this is saturated. In saturated what you are going to write? Alkane. In alkane single bond general formula is CnH2n. Now next one beta alkene and alkyne. For alkene beta, double bond, alkyne, triple bond. Okay. One is having alkene is having single bond, double bond, and triple bond. Alkene and alkyne. What is the general formula for alkene and alkyne? A general formula is Cn H2n. It is Cn H2n minus. This is alkene and alkyne general formula. Come on, go for it. Alkene and alkyne. This one draw please. Alkene and alkyne data. This is very important. So please note down. This is exactly the flow chart is very important. So you must have this information. Alkene and alkyne. Very less, very precise. So because that entire hydrocarbon will be consisted of. See, this is called as alkyl group. This is called as aryl. Aryl means chain, ring. Understood? Sorry, ring. This is chain and this part is considered as ring. Aryl and alkyl family. Alkyl family and aryl. Alkyl and aryl. Okay. So we are not talking about aryl. Aryl is out of our reach. We are not going to waste our time. We will be proceeding with the next section. Now come on, note down this one better. So now we are going to talk about saturated, unsaturated. So already we understood one part of saturated, unsaturated. We understood now alkane, alkene, and alkyne. Now beta, we are going to talk about aryl groups. Aryl groups means chain. Because till now we discussed about single bond, double bond, and triple bond. How to name it, I am going to teach it. Understood? How to name single degree, double degree, everything. I am going to degrees also. I am going to teach. But first understand cyclic or closed figures. How to write cyclic or closed figures. You give heading cyclic or closed figures. Cyclic or closed figures. Then how we are naming it also I am going to teach you. Now look at it. CH2, CH2, CH2. Then or in this direct we can do like this cycle. So whatever vertex point is there now, that is symbol of one carbon. The vertex point is exactly indicating one carbon is there. The vertex point is indicating presence of carbon. So what it is called is cyclopropane. Or it is called as beta cyclopropane. 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 Understood? Cyclopropane. But if somebody will be giving you this one, I'm just drawing it. You tell me what is the name of it. Say it. Yeah. What is the name of it? Wait, I'll draw it nicely. But what is the name we are going to write for it? Online children, come on, say. What is the name we are going to write for it? Cyclohexane. What we are going to use, beta? Cyclohexane. CYCLO. Cyclohexane. Note down. The name is exactly cyclohexane. Yes, the name is cyclohexane. Absolutely correct, beta. The name is considered as cyclohexane. What is the name? Cyclohexane. Cyclohexane. Cyclohexane, correct only. Cyclohexane. What we are going to name it as cyclohexane. Good. Everyone absolutely correct. Now can you tell me the name of this one? Cyclopentane. How many are there? 1, 2, 3, 4, 5. Means cyclo. The name is considered as cyclopentane. Note down. The name is considered as what beta? Cyclopentane. Cyclopentane. The name is what? Cyclopentane. Good, no? Understood, no? How was the class today? Did you learn nicely about the carbon isomerism we studied? After isomerism, what we are studying about? Hydrocarbon structures. Okay. Now, next, right? Functional group. I hope alkane, alkene, alkynes you are going to put one time. I'll be discussing about alkane, alkene, alkyne. Alkane, you are always writing the name as A. Ane is added. What is added? Ane. Alkane, what you are adding in the parent name? Ane. So methane, Ane is added. Propane, Ane is added. Understood? So Ane is added in that name, parent chain, parent name Ane is added, and it is symbol of single bond. Usually, single bond is supposed to be more stable than double bond and triple bond. Which is the most unstable bond is triple bond. After triple bond, second bond, that is double bond, and then single bond. So single bond is supposed to be very, very stable. Single bond is supposed to be stable bond. Remember this one? Single bond is stable. Single bond is stable. Got it? Alkene. Alkene is ene. Like methane, there is no methane. For alkene, there is no methane. It starts with ethane. So ethene. This is ethene. Note down. Propene. This is called as what? Propene. After that comes alkyne. Alkyne starts with, you need to understand that alkyne starts with triple bond, but it is not starting with methane. It will start with ethane. So it is called as ine. So ethine. Understood? What it is called as ethine. Note down. What it is called as beta? Ethine. This is saturated, unsaturated, unsaturated. Which is most stable? Stable. Most stable is this one. These are unstable. These are unstable. Unstable. Double bond and triple bond is unstable. Single bond is stable. Double or triple bond is unstable. Single bond is stable. Good morning, Himanshu. Himanshu with Sakshi. Nice. This is exactly with a single bond. This is double and triple bond. So the most important thing, double bond and triple bond. So which one is most stable? Alkane. Which one is unstable? Alkene and alkyne. Which one is unstable? Alkene and alkyne. Note down. Take your time. No need to be in hurry burry. Because naming nomenclature. Now homologous part we are going to study. So homologous next class we are going to study. Till here today, how was the class today? How was the class today? 6:15 I started, 1 hour over. Yeah. How was the class today? Understood? So now beta, I hope you might have liked the class, that okay, class is okay, satisfactory. So next class beta, because carbon and its compound means massive section we are going to study. So nomenclature, next class. Hmm. Thank you, Peter. Thank you so much. Like it, like the class. That will be the biggest thing for me. Okay. Bye bye.